Yes, sir.
Yes, sir.
विधि किया होमवर्क? ओके, ये होमवर्क दिया था मैंने, क्या आपको पूरा कंपेयर करना था? नाउ द सेकंड वैल्यू ऑफ ई इज बिटवीन 0 to 1. ये हमने पहला डिफरेंस लिख दिया था. सेकंड डिफरेंस ई के लिए हम क्या लिखेंगे? E is equal to velocity of separation upon velocity of approach के लिए हो जाएगा u1 minus u2. याद है ना ये तुम लोग को, velocity of approach and velocity of separation. So because E is less than 1, that's why we can say the velocity of separation is less than velocity of approach. Can I say that? Huh? This is E and E is less than 1. It means v2 minus v1 upon u1 minus u2 is also less than 1. Means velocity of separation is less than velocity of approach. Am I right, bachcho? Understood this?
Yes, sir.
Yes, sir.
Less than velocity of approach. Okay, now we talk about the next point. Momentum is conserved or not? Yes, it is
Conserved.
Conserved.
momentum is conserved here and here also. Your comparison may go to 2 or 3 pages back to back. And believe me, these questions can come in your school exam. Point number 3, conservation of linear momentum of system. Momentum of system is applicable here also. So m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2 we can apply here. Okay. And now the point number 4 is not valid. Kinetic energy of the system is not same. Okay. The point number 4, there is some loss in kinetic energy. So kinetic energy of final kinetic energy of system is less than initial kinetic energy of system. Do you understand that? So
Yes.
there is some loss in kinetic energy in the form of light, heat, and sound. Okay, there is a loss in kinetic energy. Loss in kinetic energy in form of light, comma, sound, and heat. Okay, bachcho? Understood point number 4?
Yes,
So
sir.
can you tell me how much loss is there? What is loss? Speak with me. M1, M2. Speak with me.
M1, M2.
1 M2
2m1 plus m2
2m1
plus
plus
2M1 plus M2
u1 minus u2 whole square
u1 minus u2 whole square.
bracket 1 minus e square.
Bracket 1 minus e square.
So this is much is loss in the kinetic energy of the system. Now if you put e is equal to 1, loss will become 0. Am I right? If you put
Yes,
e is
sir.
loss is 0, and this e is 1 when collision is elastic. For elastic collision, there is no loss. For elastic collision, there is no loss. I hope you wrote difference. I hope you did your homework. आपने किया है homework या नहीं किया है? So I hope you understand point number 4. Any doubt in that? Now write point number 5. Please click on yes if you have done your homework. Okay. Very good, very good. आप लोग homework करेंगे तो मैं बहुत मेहनत करूंगा, promise. Okay, I'll make your studies very easy if you'll do homework. Otherwise, things will become very difficult. Now, the point number 5 is the velocity of m1 and m2 after collision. So, in the next point, we will talk about what is value of v1 and what is value of v2. So, you keep in mind like this: v1 is equal to, first you will write this. First, you will write m1 plus m2 in the denominator. In the denominator, always you will write total mass, m1 plus m2. Let's write v2 also. In denominator, we'll write total mass. Okay, Shruti? Denominator में क्या आएगा हमेशा? Total mass. Okay, m1 plus m2. ठीक है देवराज? Numerator में क्या आएगा? अच्छा, पहले v1 है, तो यहाँ पे u1 आएगा और बाद में u2 आएगा. पहले u2 और फिर u1. Could you understand that? Could you understand this difference? And here m1 minus em2 USS इसके अंदर है, ठीक है. And here what you will write 1 plus e into m2. Understood? तो अब बताओ यहाँ क्या लिखना चाहिए? What I should write here in the bracket? m1 minus em2 या m2 minus em1?
M2 minus EM1.
And here 1 plus e into what? m1. Right? Now if you put e is equal to 1. Now if you put e is equal to 1 for elastic collision, what you will get? You will get this formulas. Am I right? Am I right? So better you remember this for elastic collision. Better you remember this formula. Put e is equal to 1. What v1 you will get? m1 minus m2 u1 upon m1 plus m2 plus 2 m2 u2 upon m1 plus m2. Understood, bachcho? Now put again e is equal
Yes,
to
sir.
put e is equal to 1. So you will get velocity for elastic collision m1 plus m2 plus 2 m1 u1 upon m1 plus m2. तो ये 10-10 बार लिख के याद करना है आपको, ठीक है? Write it 10 times in your copy if you want to keep these formulas in your mind. Okay? Okay, तो हमने ये भी कर लिया. There is a loss in kinetic energy of m1 only. Now there is no loss in kinetic energy of this system, but in elastic collision there is no loss in the kinetic energy of system, but in inelastic collision there is some loss in the energy, okay, in the form of sound, light and heat. I think there is no doubt in all this. These many points are more than sufficient. Okay, आगे बढ़े. Okay, give me a minute. Give me a minute. You can send message to chat faculty. Now let's write this difference for completely inelastic collision. Completely inelastic collision. क्या होता है बच्चों इसमें? After collision, two bodies start moving together and the value of E must be value of E 0. So it means that there is no velocity of separation is 0. It means velocity of separation is 0, means bodies moves together after collision. Understood, bachcho? The value of E is 0 means bodies move together after collision. Do you understand that? They become single body after collision.
Yes, sir.
Okay, so E is equal to V2 minus V1 upon U1 minus U2. Now put E 0 means V2 minus V1 is 0. It means velocity of separation is 0. So point number 2 represent velocity of separation is 0. जैसे चलती हुई बस में तुम कीचड़ फेंक दो तो कीचड़ बस में चिपक जाएगा. Am I right? Now can you apply conservation of momentum?
Yes, sir.
Yes, sir. Conservation of linear momentum of system is still valid. Momentum of system is valid. Means imagine 2 point masses m1. This is going with velocity u1, and imagine another point mass m2. And believe me, this is most easiest collision. Moving with velocity u2 before collision, and after collision they'll move together. They'll become single body. m1 and m2. They'll become single body and they'll move with a common velocity. So they have a common velocity after collision. This picture is before collision. This picture is after collision. So we can say that initial momentum m1 u1 plus m2 u2. Why plus? Because they are both are moving right, and I'm taking intentionally, I'm taking easiest example to into v. So we got m1 u1 plus m2 u2 upon m1 plus m2. Do you understand that? Understood, bacho?
Yes,
Okay.
sir.
Conservation of linear momentum is valid. No velocity of separation. The value of E is 0. Now the fourth point, what do you say about the kinetic energy? What is your opinion for the kinetic energy? Point number 4. Loss in kinetic energy. Loss in kinetic energy is maximum. Loss in kinetic energy is maximum. Okay. In completely inelastic collision. Please remember this. Okay, bacho? The loss in kinetic energy is maximum. So loss in the kinetic energy of system, the formula is same. Speak with me. Speak with me. M1, M2.
M1, M2
M2
Upon 2 into M1 plus M2.
upon 2 into
upon 2 into M1 plus M2.
U1 minus U2 whole square.
U1 minus
U1
U2 whole square.
1 minus E square. Now what is E?
1 minus E square. 0.
T square.
0. That's why loss in the kinetic energy of system is
Maximum.
maximum.
the moment you put E is equal to 0, the loss will be maximum. And if you put E is equal to 1, you will get 0 loss.
Yes.
जैसे ही E बराबर 1 रखोगे आपको ये लॉस 0 मिल जाएगा. 0 into anything will become entirely 0. So this is loss, and believe me बच्चों, this is maximum possible loss in the kinetic energy of the system. Okay. तो सबसे ज्यादा आवाज किस तरह के कोलिजन में आने वाली है?
Completely inelastic.
Because the loss is maximum in the form of sound and heat. Okay. Do you understand that? Arpit, are you there? Okay. Adis is there. Dhruv is there.
Yes, sir.
Devraj is there. Okay. Vidhi is there. Sanjli is again absent. No problem. Okay. I believe you could understand this difference. Yes, and difference in the completely elastic and completely inelastic collision. So I hope you understand what are the main 5 points. The point number 5 is velocity, which we have already written there in the point number 3. Right? The velocity of each mass after collision must be same because they will move with the common velocity after collision. Okay, so let's write point 5. Velocity after collision m1 u1 plus m2 u2 divided by m1 plus, and they'll move with the common velocity. Okay, understood? बट इसमें ट्रिकी क्या है श्रुति? सबसे बड़ी ट्रिक श्रुति ये है, आदिश ध्यान से सुनना. द बिगेस्ट प्रॉब्लम इज व्हेन यू यूज दीज फॉर्मूलाज, आपको यू विल हैव टू यूज देम इन द वेक्टर फॉर्म. कुड यू अंडरस्टैंड दैट?
Yes, sir.
Means every conservation of linear momentum you will use in vector form. The value of E, while writing formula of E, you will use vector form. Except for kinetic energy, everywhere else you will have to consider vector form. So this is main difference between elastic, inelastic, and completely inelastic collision. This was your homework. Okay, I believe you remember everything, right? Remember everything or not?
Yes, sir.
Yes.
Okay, now let's quickly revise the most important points of our last class. of elastic collision. The most important points, spatial points to remember for elastic collision, right? Only for IIT and NEET, right? Only for IIT and NEET. Spatial points to remember for elastic collision. What is value of E? Elastic collision when E is equal to 1, right? The first most important point, the momentum of individual body is not conserved. If you talk about momentum of only M1, it is not conserved. So there is some transfer in momentum. Individual body, momentum of system is conserved, but momentum of individual body is not conserved. Could you understand that?
Yes.
Kinetic energy of system is conserved, but kinetic energy of individual body is not conserved. So the most important fact, I believe, the loss in kinetic energy of the system is zero. The loss in kinetic energy of the system is zero, but the fraction of kinetic energy, the fraction of kinetic energy transferred by projectile to target, if target is at rest, u2 is 0. ठीक है, mass of projectile is m1, this is moving with velocity u1, okay, and it will collide with the target m2 which is at rest, means u2 is 0, and the type of collision is elastic before collision, and the after collision there is no doubt they'll be moving with the different velocities v1 and v2. Am I right, Vachu?
Yes.
So my point is, the what fraction of kinetic energy is transferred by projectile to target. So I represent it by delta ke by ke, means the loss in kinetic energy of m1 divided by initial kinetic energy of m1. Could you understand that? This has a formula, very fast. We have a very fast quick formula, m1 minus m2 upon m1 plus m2. यही था ना? This was the formula. Am I right?
Yes, sir.
Okay.
Yes, sir.
Let's see. देख लेते हैं. Yes, there it is. There we are. This is the formula, right? And if we solve this further, we'll get 4m1 m2 upon m1 plus m2 whole square. Am I right?
Yes, sir.
Remember the conditions, okay? Now one more thing. Copy this again, or if you remember, then there is no problem. आगे बढ़े? Okay.
Yes.
Right point. The fraction of kinetic energy retained by projectile. So from the last calculation, from the above calculation, you will do this. 1 minus delta ke by ke. That's it. Nothing new, okay? Could you understand that? 1 minus m1 minus m2 whole square. Could you understand this, what I am doing?
Yes,
Click
sir.
on, okay.
Yes, sir.
अभी माइनस को अंदर ले जाओ, 1 got cancelled and this is your answer. m1 minus m2 upon m1 plus m2 whole square. So this is the fraction of kinetic energy retained by projectile, and you are going to get a very high level question from this topic in the IIT Advanced and Mains and NEET. Okay. Now one more spatial point for the oblique collision. I believe you remember this. Oblique elastic collision. मैं मेरी बैक टू बैक क्लास है क्या? 3 से 4 भी है ना आज? 3 से 4 नहीं है आज? ओके, हालांकि मैं देख लूंगा, मेरे पास कागज है। सारी फैकल्टीज को रिमाइंडर कॉल कर दीजिएगा पेपर के लिए, मैसेज डाल दीजिएगा टेस्ट पेपर्स। ऑब्लिक इलास्टिक कोलिजन, दिस इज M1, everyone look at the, everyone be careful, everyone look at the screen, be attentive, do not sleep. M1 going with velocity u1, and this is M2. This is M2 at rest. So after collision, how they're going to move? Will they move in a straight line? Say no.
No, sir.
Okay,
No,
they'll move
sir.
obliquely. Suppose M2 is moving like this. Suppose M1 is moving like this with speed v1 at an angle, let's say theta, and M2 is moving at this angle, let's say alpha, with the horizontal, with the speed v2. So what I can write directly, and if M1 and M2 are equal, if M1 is equal to M2 is equal to M, then what I can write, and E is equal to 1, means it is elastic collision. What I can write, theta plus alpha must be
90.
very, very important for NEET student. Very, very important for all my NEET students. For IIT student, this is nothing big thing. They can prove it. Again. Okay, Sinchna? Sinchna, Shreya?
Yes, sir.
Very,
Yes, sir.
okay. If masses are same, then theta plus alpha must be 90 and M2. Second mass must be at rest. Okay. Now write point number 4. Point number 5, sorry. Point number 5. This is high level only for IIT mains oblique advance. Okay. Now it is for oblique collision. Consider oblique collision. Consider oblique collision. किताबें ले जाना बच्चों, am I audible now?
Yes, sir.
Yes, sir.
Sorry बच्चों, my iPad got disconnected. I'm so sorry. Now can you see screen? Can you see my screen? Screen now.
Yes.
Okay, now look at this. M1 and M2, they are colliding. Okay. Line of impact hers. Where is line of impact? How about which line they are going to apply force on each other?
Sir, audio is not clear.
Audio is not clear. Okay. पूजा मैम, वाईफाई वाला रूम का गेट खोला हो, देखना वहां कोई जाए नहीं, स्टोर रूम में गेट भी खोल दोगे? नहीं जाएंगे ना वैसे बच्चे वहां। वाईफाई वाले रूम का गेट खोलना होगा। और दूसरा हेडफोन है राजुल का, रेड वाला नहीं, वायरलेस वाला, वायरलेस वाला देखो। हाँ, ऑडियो इज नॉट क्लियर। बच्चों को चुप रहने बोलना, सारे क्लासेस की गेट लगवा दो, थोड़ा सा धीरे बात करें, ऐसा नहीं, चुप, डांटिएगा मत। गिव मी अ मिनट। किसी और चीज से हो गया। Now my voice is okay?
Yes, sir.
Now is it okay? Okay.
Yes, sir.
Oh my God. चक्कर आ रहे थे क्या? अभी बेड निकाल के लेटाओ इनको। लगी? वेट अ मिनट बच्चों। लगी तो नहीं? चक्कर आए उनको, इतनी तेज चक्कर में गिरते हैं। ओके चलो आ जाओ बच्चों, कोई बात नहीं, लगते रहता है। द लाइन ऑफ इम्पैक्ट इज अलोंग, कैन यू सी दिस? ये एक दूसरे को यहां से टच कर रहे हैं, दे आर टचिंग ईच अदर एट दिस पॉइंट, राइट? सो दिस शुड बी लाइन ऑफ इम्पैक्ट, एम आई राइट? This should be line of impact. What do you say? What is your opinion, bachcho?
Yes, sir.
Okay, if this is line of impact, let's every time to find line of impact, you connect them center to center. Okay, connect their centers. This is suppose this is center of M1 and this is center of M2. Join their centers by a straight line, or you can draw radius. So this is known as line of impact. Oh no. Understood, bachcho? This is known as line of impact. Understood?
Yes.
Okay. Can anyone explain me where momentum of only M1? Listen again. They will apply a force along line of impact on each other. Yes or no? They will apply force on each other along line of impact.
Yes, sir.
Yes, sir.
They'll apply. Okay. So now imagine only about M1. So there is force on M1 along this line of impact. Imagine a line which is perpendicular to line of impact. Imagine a line which is perpendicular to line of impact. समझ पा रहे हैं क्या है ये?
Yes, sir.
This is a line which is perpendicular to line of impact. Now if I comment momentum of M1 and M2 individually conserved about red line, I am right or wrong? See, there is no force along red line. Do you agree? Surface of the both the spheres completely smooth. If I say there is no force along red line, am I right? Not even internal force. Not even, because internal force is along impact of line. Imagine these two bodies are colliding with each other. So where they will apply force on each other?
On line of impact.
Along line of impact. So Sinchana along red line there is no force. Am I right, Shreya? Am I right, Chinmay? Am I right, Adis? Dhruv?
Yes, sir.
Devraj,
Yes.
please
Yes,
respond.
sir.
Yes, sir.
Okay.
Yes, sir.
Thank you, everyone. Paras understood?
Yes, sir.
This is only for IT advanced. Okay. So along red line, this is a line perpendicular to line of impact. This is a line perpendicular. Usually momentum of M1 and M2 is conserved because along this line there is no force. Along a line which is perpendicular to line of impact, there is no force. There is no force on each M1 and M2. So, not even internal force. Not even internal force. Am I right? So, if we talk about individual body, so for only M1, the momentum of M1, I'm not talking about system. Momentum of M1 is conserved about which line? Blue line or red line?
Red line.
Red line. Red line.
Red line. Now, red line is a line perpendicular to line of
Impact.
impact. Okay. So now if we talk about only for M1, for only M2, its momentum is conserved about red line individually. Could you understand that?
Yes.
It is a very high level point, not for your school exam. Consider oblique collision, oblique elastic or inelastic, whatever. ठीक है, पेन रिलीफ दे दो उसको, एक ठंड है, कुछ खिला दो भैया, जूस वूस पिला दो, ऐसे थोड़ी गिरता है कोई, खिलाया था, ग्लूकोज दे दो, बीपी चेक करवा देना आते सर से, कोई बड़ी समस्या तो नहीं है, ऐसे थोड़ी गिरता है कोई. Copied everyone?
Yes, sir.
Okay. थोड़ी पाप कम करो तो ऐसे गिरते पड़ते फिर. Wait, I'm giving you a good question. Wait a minute. Okay. Write this question, everyone. These are my favorite questions. Question number 1, level 1. Now we are solving level 1 question. Tough from school point of view. An object स्पेस छोड़ा था मैम, अरे वाह. An object moving horizontally with speed u collides elastically with another object of mass m2 at rest. Select correct statements. Let me make a diagram. Give me a minute. This is m1 moving with velocity u horizontally, and this is m2. This is m2 at rest. Okay. Now they made a line here, SR. There is a line SR passing from center of each sphere. थोड़ा सा इसको ऐसे. Now perfect. There is another line, PQ. Okay. Now option 1 is saying the momentum of system is conserved only in direction PQ. Give me a minute. I need some more space to write options. I'll minimize. Okay. I hope you can read, still you can read questions. So option A is saying the momentum of system मुझे लगा कंप्यूटर गिर गया is conserved only in direction PQ. Momentum of M1 is conserved in direction perpendicular to SR. Point number 3, momentum of M2 will change in direction normal to CR. I made C. Point number 4, all of these. Okay. I'm waiting for your answer. You can send answer in the chat, faculty. It's sent hello to everyone. Send me answer here. Chinmay saying, Chinmay given the answer. Fastest one is the Chinmay. Fastest finger first में Chinmay आ गई है KBC की hot seat पर. Paras second fastest and correct. Chinmay and Paras both are correct. I want to see if any class 11th student give correct answer. Vidhi, try please. जल्दी करो. Arpit Singh third. Okay. One more. I want one more. Dhruv Devraj, Adis. I want answer from Shruti. Okay, no problem, Arpit. Shruti is saying 4. And Shruti is 100% wrong. 200% wrong. Dhruv is right. Dhruv is right. Everyone clap for Dhruv. Shreya is wrong. Devraj is wrong. I think Dhruv is right. Okay, now let me explain you. The momentum of system is conserved only in the direction of PQ. No. Momentum of the system is conserved everywhere. Because yes, there will be a force of interaction, but that is an internal force. So momentum of the system is conserved along all directions. So this is wrong. Momentum is conserved. Momentum of system in all possible directions. Momentum of system. Okay. Now if you talk about individual body, if you talk about only M1, okay. So where is in which direction there is a force on M1? Where there is a force on M1 in this direction. Am I right?
Yes.
Am I right? So momentum of M1 will change along SR, right? Momentum of M1 will change along SR. Say yes.
Yes, sir.
Yes, sir.
So where momentum of M1 will not change? In which direction there is no force on M1?
Normal to SR.
Normal to SR. There is no force on M1 along green line. So momentum of M1 is conserved in a perpendicular direction of SR. Could you understand that?
Yes, sir.
So second is correct. So Dhruv, Paras, when one more student, I forgot name, Chinmay. Only 3 students could give answer of this question. This is exact ID advanced level. This is wrong. Momentum of M2 will change normal to CR. No. Momentum of M2 will change along SR or CR. Momentum of M2 will change along CR. Could you understand that? Normal to CR, there will be no change in the momentum of M2. तो बताओ M2 का momentum कहाँ बदलेगा? Along CR, momentum of M2 will change. But a line perpendicular to SR or CR, momentum of M2 will not change. Could you understand that? क्या करते हो तुम लोग बच्चों? अभी सिखाया ना मैंने, इतनी देर तक क्या सिखा रहा था ये मैं? कहाँ ध्यान है तुम लोगों का? Understood or not?
Yes, sir.
Okay. So now let's move towards our next topic. Instead of teaching you another topic, I want to give you another question, another easy question, because I believe there is some problem in the concepts. Write this question: velocity of the ball A after collision. Assume perfectly inelastic head-on collision. मौसम खराब है, I can understand there is some network problem, so don't worry, I'll send these notes, and this class is live on YouTube, so you can rejoin, you can attend this class through YouTube again. So there should be not any problem, I believe. 2 meter per second. If I assume 5 as plus, I will assume 2 as minus. Could you understand that?
Minus.
Velocity is a vector quantity, okay? So velocity of ball A after collision with ball B. So after collision, they'll move as a single body, right? The mass will become 7 kg. Could you understand that?
Yes, sir.
After collision. Now, which side momentum is bigger? Which momentum is bigger, left or right? 5 2s are 10, 5 2s are 10. After collision, they'll become a single body. I'll give you options. The option 1 is 3 by 7 meter per second. After collision, they'll become single body. Momentum before collision is equal to after collision. What is your opinion? What is your answer? What is your answer? कौन लीव कर गया भाई? D. Two students said D, and they answered very fast. Chinmay again fastest, second fastest again Paras, and they are correct. See, what is the initial momentum of the system before collision? 2 into 5 plus minus 2 into 5. So initial momentum is 10 minus 10, which is 0. Initial momentum of the system is 0. Am I right? Click on yes if I am right.
Yes,
Click on yes. Click on yes. Okay. So what should be the final momentum of system? Let's say its velocity is v. So final momentum is 7v. Initial momentum and final momentum must be equal. So v is equal to 0. Understood? Understood, everyone?
Yes, sir.
Okay. Means concepts are okay. But only again 2 students answered. This is not good. Now I want to show you, I made one homework for you all. One classwork sheet, actually we will solve these questions in the class. पूजा मैम ने अभी भेजा ना मेरे को, सेंट में होगा क्या? अभी नोटिफिकेशन आया था, ये रहा। Okay, this is your this is our classwork. The total number of questions, 1, 2. Okay. Going. These many questions we are going to solve. Keep going. So we have two options. I can keep solving every question, 40 questions of elastic and inelastic, and 20 questions of perfectly inelastic collision. We have two options. Either I solve each and every question, or first you attempt this sheet and then you ask only doubts. Tell me what you want. What do you prefer? Only doubts or entire question we should solve together? Okay, so first you attempt, everyone. Please attempt today itself. And there is no problem if you are asking 19 questions out of 20, no problem at all. Okay, mark question number. Everyone, please mark question number and the topic. We have two topics: completely inelastic collision and normal inelastic and elastic collision. Total 60 questions we have. Okay, so you need to solve only these 60 questions. This chapter is officially over. Only one topic is left: the relationship between conservative force and energy. We'll do it tomorrow. Okay, tomorrow you all will come with your doubts. Okay, promise me you will solve this. Everyone will say promise. Yes, sir, we will solve each and every question. Come on. Send me promise in the chat box. Okay. Yes, नहीं चाहिए, promise चाहिए क्या? Okay. Adis, give commitment. Paras, Shreya, Dhruv, okay. Chinmay, in the chat box, Shruti, Arpit, Devraj. Okay. Shreya already did. Sinchana, where is your promise? Vidhi? Okay. Sinchana did promise. Vidhi? Send me message, Vidhi. Okay. That's it for today. I'm leaving you early. I will send you these questions in your mobile. You can take printout or you can solve from mobile directly. But please write these questions in your copy. Okay. Notes also I will send. Don't worry. Okay, bachcho, enjoy. Have a nice day. Bye-bye. Take care. बाय बच्चों, टेक केयर. बाय तक नहीं बोलते तुम लोग ना बेटा, मिलो
Bye,
पिटोगे
sir.
बहुत.